My name is Stephen Costa. I'm an AEC BIM specialist here at Microsol Resources. My background's in civil engineering and infrastructure design. I worked for a firm here in New York City for approximately 6.5 years doing mostly transportation and utility work. And having since joined Microsol Resources, I've now used some of that background knowledge to participate in helping out our clients in understanding how to use technology, specifically within the infrastructure world, but certainly within the architectural engineering and construction community, to leverage technology to improve and just better the overall design process. So today's webinar, in particular, will address a topic that I know some of you have spoken to me through our day-to-day interactions, things that I've read online and in publications, and that's really discussing how to facilitate the conceptual design phase. Really specifically, we're talking about rapid visualization. What I'd like to just start with a quick discussion on is the idea behind what that process involves, and it's really transforming data into information. So with the context of geospatial data, what we'd like to do is convert, this two-dimensional, almost database-driven data, as it's called, into something a little bit more informative. In the context of the technology that you're going to see today, InfraWorks360, that's really taking that 2D data and converting into a 3D visualization space. And you'll see that we'll be able to take a lot of information ranging from roads to buildings to trees to fire hydrants, anything that you can imagine in the real world that would improve your understanding of a given site will be readily accomplished by converting that two-dimensional, flat, uninteresting data into something that we can all visualize. Namely for, obviously, the design process, right? It's easy to conceptualize something that you can view in 3D, but also for discussing any project-related meetings in an environment where not everyone may be either an engineer or an architect. So in that context, I'd like to just talk a little bit about that. Now, when it comes to the project that I'll be discussing, it really happened quite randomly, and I try to treat this webinar as a presentation I did a few months ago as something sort of out of the box, meaning not something scripted, not something that you could get online and watch a video of using data that was already sort of built into the demonstration. So what I did was I hunted around for a couple of architectural design competitions, and I found one that was based out of the United States, just to even make things a little bit more tricky as far as I was concerned. And I stumbled across a relatively small design competition in Copenhagen, and it was for the design of a new modern library along the waterfront. So I went and I collected as much information as I could regarding this, and ultimately the goal of putting together a presentation like this was to show you that from nothing we would be able to aggregate a bunch of information to really help us make informed and transparent design decisions based on what we were hopefully trying to accomplish. And in this case, if you're entering a design competition, coming up with a design that would help you win. Obviously, the first step in that would be understanding what your environment is, what information is available to you from a number of different angles. So what it comes down to is, as far as design decisions are concerned, is really about two things, input and output. Now, the input is finding the data, the output is transforming that data into something relevant. Now again, the tricky part about geospatial information, and in the context of today's presentation with regards to InfraWorks, is finding relevant data. Now, it requires a good amount of effort to go ahead and find the relevant data that you would need. Now, in the particular example that I was, the Copenhagen project, it started off with a quick understanding of the site. Here in red is the area of the site. What I had pointed out, and I'll back up the slide so it makes it a little bit easier for those of you to follow along, right? So I was given this as a DWG file, and as I pointed out, the surrounding buildings were the important part for controlling how large that overall project could be in terms of height. Its important prominence along the waterfront, traveled by both tourists and locals alike, was a concern, as was one of the prominent buildings in the area across the waterway, which is the Copenhagen Opera House. Immediately adjacent are the Royal Residential Winter Palace, and south of the site, you had the Copenhagen Music House. Now, just taking that information, you really are left with kind of nothing. I had a 2D CAD drawing with some hatching, some lines. I had no idea of space in terms of geometry. I had no idea of the way that the site really looked. So the first thing that I thought of from an infrastructure perspective was how to collect GIS data that would sort of flesh that site out. And that was the goal that I had in mind for today's presentation. So talking a little bit about geospatial information, it really comes in two flavors, vector data and raster data. Vector data can be essentially anything that you can associate with a vector type object. So things, lines, points, polygons, right? So a line could be represented, for instance, as a roadway, or a polygon could be a building, or a point could be a tree or a lamppost, things like that. Raster information is slightly different, and that really just correlates to, if we're talking about a site, photometric aerials of a particular site, things like that, photos essentially. So if you were boiling it down to those two kind of objects, how would we go about finding that information? And the most obvious answer is simply just research. Now, I did spend, and I would say, the most amount of time actually researching rather than putting everything together. In fact, in the remaining time, I'll actually be able to put together all the things that I found within the 40 minutes that we have left. So it gives you an idea of, considering that I spent probably hours, if not days, just doing a good amount of research, finding what was available to me. Now, as mentioned earlier by Annalisa, I'll be providing a number of sites where I found information for this particular location, as well as spending some time after the fact talking about something more local, right? I'm assuming that most of you are within the tri-state area, so a project in Copenhagen may be of little relevance, but the process I used to get there is going to be exactly the same. So if you can apply the process that you're going to see today with regards to this site and a handful of other demonstrations that I'll give, you can pretty much use it to find anything else. Next comes the analysis of that, and I'll spend a little bit of time talking about how to analyze the data. And it's actually quite straightforward. I'm going to be using several tools, both Civil 3D and InfraWorks to use this, as well as throwing Revit into the mix for the analysis of what the proposed site may include. Right? I'll use a pretty dummy Revit model just to give you an idea of how it works, and then talk a little bit about all three processes, right? Civil 3D, Revit, and InfraWorks, and how they work together. And then last but not least, no conversation about infrastructure would be complete without a discussion on coordinate systems. It'll sort of play the back seat here in terms of what you see in the presentation, but know that understanding where you are in the world with regards to your project is very important. Architecturally speaking, you can start any design by arbitrarily choosing a point in space and basing your design off that. But with geospatial information, context is quite important. So where a site is located in the world and what coordinate systems are being used to overlay that information becomes definitely a point of concern. And then last but not least, one central other point that's worth mentioning with regards to GIS information is it's quite useless without metadata. Now, metadata can include any number of parameters that you would associate with that real-world representation of the geometry that you get from geospatial information. So the examples I gave earlier for vector information and for raster information boil down to how much metadata comes embedded with that. So for example, if I have the footprint of a building, if I would like to understand a little bit more about its height, perhaps some of the metadata that would help me would be, for instance, the number of floors associated with that building. Or if I had a road, understanding maybe what its name, the name of that roadway is, or the type of utility that road is for. Is it a local road? Is it an arterial? Things like that. In the case of raster information, usually a orthographic image of the surrounding site is geo-referenced, as the term goes, so that it knows where it resides in the real world. All those are examples of metadata, and they will play a pretty solid part in understanding what information is available. So with that, I'm going to just jump into the presentation. Go ahead and end these and talk a little bit about InfraWorks, as well as give you an understanding of all the design steps I took to get from from essentially a CAD file to this. So I'll start by talking a little bit about InfraWorks. The screen that you're seeing at the moment is the InfraWorks splash screen, or not splash screen, I should say, the welcome page. Just so that you know, there are two flavors of InfraWorks. InfraWorks that comes with your design suites and InfraWorks360. Most of what you're going to be seeing, with one exception, is going to be available in the InfraWorks that comes either with your building design suites or your infrastructure design suites. And then there's one thing that I'll show off right off the bat, which is part of your InfraWorks360. There is a comparison matrix that I'll bring up at the end of the presentation that gives you all the details, and that will be something we provide as well with the follow-up that we send out. Now, what I'd like to start is just with a very quick understanding of what you're up against when you choose any design project that you'd like to be working with and the starting step for collecting that data. Now, fortunately, as part of Autodesk 360 and InfraWorks 360, there's a tool called the Model Builder. And I'm going to demonstrate that very quickly to give you an example of how that information would be collected. And you can see here that I can simply choose Model Builder, and it brings me a map interface where I can go ahead and type in an area of interest or an address, and it would take me to that location. So, for example, if I go ahead and type in our address, you can see here I'm zoomed into New York City. I'm just going to use this area right off the bat to collect data. Now, you can see I have the ability to collect up to 200 square kilometers of information. Now, what Model Builder does is it leverages open source GIS information through a number of online repositories to get you started. So if you're saying I need to start a project in this location, what information is readily available to me in terms of roads, in terms of bodies of water, in terms of railways, buildings, etc. Right? So the purpose of Model Builder is to get you at least started on the right foot. So I'm going to go ahead and just give this a name. I'm going to call this Microsol Resources HQ, and I'm going to go ahead and just click Create Model. And now I'll get a little information that my model is being prepared, and I'll be notified in several minutes when it's ready. So I'm going to just close that, and we'll come back to that a little bit later. What I did do with the project I'm going to show you is start off with the Model Builder. And you can see as I open it directly, this is what information I pulled from Model Builder, right? Now, at a glance, it's actually quite impressive, right? You can see that if I zoom in, I have a number of bodies of water. I have some roadway information. I have some building information. And geographically and relatively speaking, we're looking at a site that gives me a very good idea of where I want to be. Now, of course, I'm going here with the idea that I already knew where the site was based on the design competition and some minor research on Google Maps to find out where that area is. And so you can see here, as I hover my mouse around, that would be our project site. Now, some of the information that's already here is useful from a very, very early design phase, but if we start really looking at the details, we're going to find ourselves a bit disappointed. Not because the tool didn't work the way it was intended to, but because some of the geospatial information that was available through those open sources isn't exactly as precise as we'd want it to be. So for example, if I were to zoom in here and I take a look and I would compare this to, let's say, Google Earth, I would see that the buildings aren't exactly the right height. I would see that, for example, the raster information is a little bit blurry when I zoom in. I can see, if I again were to just do some research using other platforms like Google Map or Google Earth, that indeed there isn't a roadway here, it's really a walkway, and things of that nature. So understanding that right off the bat is quite important in then utilizing InfraWorks to collect your data. All right, so how do we go about changing this to something that we need? Now, again, for the purposes of this design, for the purposes of this webinar, I'm not going to go through the entire design process from beginning to end. I'll jump the gun by saying that the earlier slide where I showed you some of the websites associated with the research I did, I was able to collect a good amount of geospatial information. So I'm going to go ahead and bring that up for us, right? And I'm just going to just browse and just show you a folder, nothing more, that just has information about various sources. Now, most of this information is in a geospatial format called the shape file. So you can see here if I go to Copenhagen data and I look at base map shape, there are several files, but one particular file extension, an Esri shapefile, is the one that's most common for this type of information. Now, there's a plethora of ways that you can import information inside of InfraWorks, so I'll just point that out as well. If you take a look here at the data sources that you can bring in, as I bring that drop down, you can see that anything from an AutoCAD file to a 3D model, Revit, RASTER, point cloud, LendXML, SketchUp is readily available. The one that I'll point out here is the shapefile, but one of the nice features of InfraWorks is the ability to just drag and drop, so I don't really have to fiddle around with, well, what kind of type of object am I bringing in? You'll see that I'll be able to just drag and drop that. So that being said, I went and I found tons of information that would help build up this site. Now, when it comes in a geospatial format, it is 2D information. And what do I mean by that? Well, to understand that, you need to be able to see it, right, rather than me just saying it. So I'm going to fire up another application for the time being, Civil 3D. And I'm just going to go ahead and just start off a blank drawing, right? Just so that you have an understanding at a very cursory glance of what geospatial information really is. And I'll point out things like the ones I pointed out earlier, which is specifically vector information and metadata associated with that. So using Civil 3D, which is part of the infrastructure design suite, I can go ahead and toggle a planning and analysis workspace. In here, I'll be able to just simply either connect to any amount of data that I want, or as I mentioned before, simply drag and drop. So if I go ahead and I split my screen up into two sections, right, I'm just going to bring up some information that I have readily available. Now you can see here that I have several different types of information within this Copenhagen data folder. It was off of a website that was run by the local government, the Copenhagen municipality. And from there, I was able to actually pull in a ton of data. And just for the fun of it, I'll go ahead and I'll just show you that, there's no smoke and mirrors, data.kk.dk, right? So from here, using Google Translate, I was able to go ahead and read the site, find out what information I needed. So for example, if I wanted to go to data sets and I could translate again, you'd see that there are a number of things that I could download, shape files, CSV files, etc. So don't be afraid to go online and just do a quick Google search. I'll spend a little bit of time later talking about the search process in particular, so don't worry about that at the moment. So using that methodology, I was able to pull a ton of information. So I'm going to go ahead and just throw a couple of things up on the screen for you to see. And one of them that I found immediately was information relating to buildings, right? And you can see here the Danish word for buildings. All I have to do is simply drag and drop that information into my drawing. And you can see here I have information about the site, right? I know more or less where it is, so I can zoom into immediately. This is the project area site. And you can see that there are polygons that represent my building footprints. Well, that's great. I can use that information just as well as I can use the information that was inside my InfraWorks. Well, what other kinds of information would be relevant? So if I go in here, I can find some additional types of information. For instance, I can go ahead and find roadways, right? So you can see I just drag and dropped the Danish word for roadways into here, right? And you start building up an idea of, let's say, maybe light poles. Right? If I go in here and I drag those in, I now have some light poles. So using that technique, and you would do this for as much information as you could find or would be relevant to your project, you can see that I have some two-dimensional data. Now, again, this doesn't really paint a pretty picture. This doesn't help us understand more about the site other than maybe slightly more detail in the two-dimensional world. So the ultimate goal would be to take this information and make it sing inside of a product like InfraWorks. Before I do that, though, I want to just point out what I meant earlier by metadata. So you can see that I've brought in poles, right, street center lines, and buildings, right? Again, those are the Danish words for those objects. If I want to understand a little bit about the information that's embedded, I have a tool that allows me to view the metadata for, let's say, a street name. Right? So you can see here, all this information is metadata. So for instance, I can see the street name for all the different streets within that area. If I go to the different types of poles, I can see that there are light poles, and you can see here by the object type, most of them are considered poles, and then there's electrical, there's light, there's unspecified. Again, I made this a little bit more difficult in the sense that I was researching information in a language that was foreign to me, but it just goes to show that a little bit of research goes a long way into understanding. And as an example, all I did was I used Google Translate to go and find, the Danish word and its equivalents in in English, right? So I had a very clear understanding of the types of information that I was working with. Rest assured, I'll give you an example later on of information I found in New York City, and I found in Westchester County, and I can find in Boston, and so on and so forth. So we'll get there shortly. So these are examples of metadata. Well, how does that really help me? Well, there are going to be certain things that I might want to leverage inside of InfraWorks. So the next step would be to take this information, collect it inside of InfraWorks, and really utilize what I want to flesh out the site a bit more accurately. Now, there are certain types of information you may be looking for that you're not going to find just through a series of web searches. I went as far as to reaching out via email to the Copenhagen municipality asking for information, and they were actually quite readily willing to provide me the information that I needed. So much so that one of the things that I needed was a more accurate depiction of the buildings surrounding the area, since I didn't have the information that I would like. And they assured me that actually by January of this year, which is the month that we're in now, the information would be available. And when I reached out to them in January, they provided me a link where I was able to download all the information I needed. Now, that's going to be especially important because of one of the stipulations of the design process, right? If you recall, the very first thing that I mentioned was that the site location, which you're seeing here, couldn't be designed to a height larger than the surrounding area. Now, again, as I pointed out, using other methods of checking, I could do my research and due diligence and see that these buildings are represented fairly arbitrarily, right? There's building heights associated with them, but there's no metadata to it. I can't control that metadata to ensure that the design shows me something accurate, right? So the next step I would take after considering and downloading and researching and understanding the metadata within the files that I acquired through the GIS clearinghouse is to decide what's still relevant from the things that the model builder provided and what information I'd like to go ahead and utilize to the extent that I could flesh out this design to a very fairly more accurate location, right? So I take a look here at my data sources, and I can see that I have buildings, I have ground imagery, railways, which I won't need, at least not for this context, roads, terrain, and some water areas. Now, the first thing I'm going to go ahead and nix is the buildings, because like I said, while they provide some general context, they're not very useful in the sense that they're not really realistic. So I'm going to go ahead and just remove that data source. I'm going to go ahead and also, if I zoom in here, this raster information is quite poor, right? And I actually found information that was significantly more high resolution for free. So I'm going to go ahead and just get rid of that as well. And you'll see that all I'll be left with is the terrain at this location, right? And then the roads I'll keep, and the water bodies I'll keep, and the railways I'll keep because they provide context, and for they're not offensive to the visual aspect of what it is that I'm ultimately trying to show here. So how do I recuperate the information that I had using InfraWorks, right? I need some more high quality data. I was able to find that online for free. Now the trick is, after understanding the data in a platform like Civil 3D or any other GIS data, right? Esri provides, I forget the name of their, I think it's GIS Explorer. There's some freeware called QGIS, right? Any information that you can utilize to view that GIS is beneficial. I like the added benefit of being able to pull that information to Civil 3D and then bring in all sorts of other data. I will jump back and say that I also found, for instance, within that municipality website, a drawing file that contained the information for some of the surrounding area, right? So if I go to my data sources and I go to drawing files, I can bring in a partial map of the DWG files associated with where those buildings are, showing where there's water valves and manholes and trees, etc. Again, simple 2D data, but it really helps build an understanding of what it is that I'm actually after when it comes to showing this two-dimensional data in 3D. So the first thing I'm going to do is overlay the orthographic photo that I found. Now, I'm going to point out something that's actually quite interesting in the sense that if I were to browse that file and show you how large that file size is, you would probably maybe be shocked, maybe not, what do I know. But if you take a look, I found some geospatial information that's about 3 gigs worth of ortho photos. Now, this is an enormous site, right? It covers most of the surrounding area outside of Copenhagen as well as Copenhagen. So, right, it's way too much data at this point. So one thing that I'd like to point out is that after you've come in here and you've brought in the information that you'd like, I suggest whittling down that site to just the information you need. So I'm going to go ahead and bring up my model properties and go ahead and, where's my model properties, and go ahead and just choose interactively a site location, right? I'm going to just go from there to there, there to there, maybe like that, maybe to there, to there, and right. And so I'm effectively clipping the area of the model that I want to be working with, right? So you can see here I'm now working with a lot less information. It'll actually make the whole integration process a lot simpler. Now what I'll point out is I'm going to go ahead and bring in that 3 gig file and just drag and drop, right? And it already knows that it's ground imagery because it's raster information that has a georeference. It knows the coordinate system that it needs to come in. The only thing I want to double check is the fact that it's clipping to the model extent, so I don't bring in the entire model. And you can see I'm running on a laptop. This 3 gig file is being processed extremely quickly, and it'll be clipped to the area that I chose. And you're going to notice that the resolution for that raster data is far, I mean, by, I would say, a good amount more high res than the information I had earlier, right? So you can see a lot more detail than you had earlier, right? So using Model Builder, it's a great start, but this raster information is far more high resolution. All right, so that was one of the steps. Now, how do I flesh out the rest of the buildings that I brought in? Well, I found some data that I mentioned earlier. I'm going to go ahead and bring that in. Again, I'll just point it out that I'm going to do a simple drag and drop. Go to my data sources. I'm going to go to the buildings, and you're going to see that I have a couple of building areas that I'd like to bring in. You'll see here that I can bring in either this as a civil 3D drawing or an AutoCAD drawing. I'm going to bring it in as an AutoCAD drawing. And as it processes, it'll find information. This time I'll tell it it's a building, set of buildings, and I'm going to use the coordinate system that is relevant to the project. I'm going to close and refresh. And as it builds that information, you can see that now. And I'll toggle a quick setting to give it a better appearance. Let's go to my application options, 3D graphics. And let me go to my visual effects and turn on ambient occlusion. And you can see that now I have a very crystal clear understanding of the site and its general location. So much so that I can actually take a look at the georeference TIFF, see where the shadows were from the ground, look at my building, and use some of the sun and sky settings to change the time of day and the year so that my shadows that are being cast by the sun within InfraWorks almost match exactly the shadows being cast by the georeferenced TIFF. That way it gives you, again, a little more sense of realism to have the data being at least shadowed in a similar way. Now, it's not going to be exact in the same every location, but it gives you a sense of realism that you would otherwise be missing. All right, so again, I've just brought in all those buildings right off the bat. I'll point out that you don't need to ever actually save anything inside InfraWorks. Everything is actively being written to a SQL backend. So if I were to exit this and then come back in, I'm back exactly where I left off. All right. So other types of information that I pointed out earlier were the buildings. Now I'm going to go and try to flesh out this overall design with some more data. Now, I mentioned earlier that the Opera House, located right where my mouse is sort of hovering, was important in the design considerations, right? Now, I can bring that information in from the buildings I wanted, or I can bring it in through a different methodology, and I'll just go ahead and I'll do that just to give you an idea of the flexibility that InfraWorks offers. So for now, I'm going to go ahead and just browse, and using the Trimble database for SketchUp files, I went and I found, if I go ahead and I browse to my data sets, I found some SketchUp files, and I found a number of things, most notably the Copenhagen Opera House. And here's just a quick tip. If you're working with InfraWorks and you're bringing in SketchUp data, if you bring up the SKP file, it'll come in fine, but none of the materials will be mapped. So one quick little tidbit, if you're working with SketchUp and you want to bring it in, I suggest opening it up and exporting it out as a collada file. That's a DAE extension. And then you'll see that when you do that, you create the collada file as well as a folder with all the materials. So that way you'll get proper mapping of the resources that came from the SketchUp drawing. Now all I need to do is drag and drop once again. Now this time I'm going to use a slightly different methodology. You can see here that my model of the Opera House is located right there. A lot more photorealistic, right? I have a lot of detail there that it wouldn't be readily available to me. The only thing that I need to point out is that fact that it's a building and it needs to be geolocated. Now in the case of SketchUp, it's not always the case. So what InfraWorks offers is something known as interactive placing. So I can go ahead and just bring that information in, sort of hover. I can use my control middle mouse button to scale. I can use Shift to move up and down, and I can use Alt to rotate, right? So all I'm doing is holding out either Alt, Shift, or Control and scrolling my mouse wheel to change that information. And then I have to just double click to place it, close and refresh, and now I have that data in my drawing, right? Again, a lot more realistic than just a blob or a generic rectangle that shows me where that information resides. And then last but not least, since it's about 11:40 and there are other things I want to talk about, I'm going to bring in a handful of other things quite quickly. So I'm going to go ahead and just bring up my directory, and let's go ahead and just bring in some data set sources. I'm going to go ahead and just start off by bringing in, for example, let's bring in some light poles, right? I'm going to go ahead and just select light poles, and I'm going to, for the sake of simplicity, say that that's some city furniture. It's a terminology associated with InfraWorks. I'm going to tell it it should be located in the right coordinate system and that it should drape on top of the surface. All right. I'm also going to assign a style that says, make those light poles look like these types of street lamps. Now, I'm glossing over the fact that InfraWorks comes with an extensive library of parts that you can drop in: light poles, newspaper stands, magazine kiosks, hot dog stands, street lights, etc. All I would need to simply do is select a type and hit OK. I also can bring in 3D files from other applications like 3ds Max, AutoCAD, and create my own versions of these model furniture. So you definitely have that flexibility as well. So by assigning streetlights to all those different types of vector objects, I can click close and refresh. And now, instead of having something that just is represented in AutoCAD Civil 3D as maybe, let's just say, let me turn off the reference to make it a little bit easier to see, right? Rather than have a simple dot that represents my light pole, I now have a three-dimensional object, right? So wherever there were light poles on that project, I can now see them in 3D, all right? Same goes for a couple of other things, right? Let me go ahead and just find some bollards and some cycle. Let's go ahead and just add some more of those information, right? So I can go ahead and bring in, let's bring in this. Oops, wrong file, right? These are drop inlets, right? So if I go ahead and I just make the city furniture and I assign it the right coordinate system and I just hit close and refresh, you're going to see that just without assigning a style, it's going to just drop in some generic information in there, right? So let's let it refresh. And if I take a look around, I should see a handful of objects where we have drop inlets, right? You can see here they're fairly generic little blobs of information. What I would want to do is go in there and change that so that the style associated with it, either a manhole cover or some sort of drop inlet. Let's take a look at my options, maybe a street grate, and click OK, and click close and refresh. And you're going to see it's going to transform all this data into street grates. And you just keep repeating this design process over and over again for all the things you need until your site is fleshed out to the degree that you'd like it to be. Now, one thing I probably didn't double check, because it is taking a little bit longer, is the fact that I probably didn't clip to model extent. So you can see it took a little bit longer to load. After I clip it, it's a lot quicker. Right? So I have little drop inlets where that information is. I can delete things that I don't need. This is not really a road, it's a walkway. I can go ahead and delete that. You can see I have a drop inlet in there. And then last but not least, for the sake of time, I'll bring in some trees. Now, I'll point out again, the flexibility and power that you have inside of Civil 3D and inside of InfraWorks, and then ultimately you'll see inside of Revit as well. I had a bunch of information for where trees were located. These were these M's. Now, I didn't have that in geospatial information. Long story short, Civil 3D can publish geospatial information. So I found a cool little list routine that allowed me to change. If I go to my projects and I show you this list, there is a text to block list. So I was able to convert all that text element into blocks that I was able to then publish to geospatial format as a dot, right? That dot was then geo-referenced into the right location. And what I can do is take that information that I have, which is I called user-defined trees, drag that in there, assign it to a tree section, and let's go ahead and just give it a generic type of tree, right? Let's just say that type of tree, close and refresh, and I now have information about where trees are located, right? So all the trees in that surrounding area are presented to me from information that came as just M-text, right? So extremely powerful. Now, I'll point out that you can randomize the types of trees that you have using something known as a style rule. So I'll do that very quickly just to give you a flavor of how powerful that is. I can create a new style rule that I'll call random trees. I'll go ahead and I'll edit that, and I'll add to this mix the main tree that I wanted plus a handful of others just to give you all weighted the same, meaning that they'll use them all to equal amounts. I'll run those rules, and you can see now I have a little bit of variation in my trees and sizes and in types. You can also control using a little bit of JavaScript the scale of those, right? So if you have a programmer in-house, know somebody who knows a little bit of JavaScript, or simply search the web, you will be able to find ways to randomize the tree heights as well. All right. Now, with that, I'll take a break and move on to another topic, but you can get the idea that as you were putting this information together, anything that you have in 2D dimensional data can be transformed quite easily into 3D to give you an overall understanding of what your site looks like. Now, in the context of what I talked about earlier, you can see that my Microsol Resources HQ is ready. It's probably been ready for about 20-30 minutes, but I just wanted to go in there and just pull that information in. You can see it's downloading right now, and you'll see exactly what, it's going a bit slower than I'd like, so I may cancel that, but you'll see that it brings in all the data from the site that I have. There we go, that's a lot quicker. And as I go ahead and I open it up, you'll see the area that I selected in 3D. Again, you're seeing it's bringing in some imagery. It's going to bring in whatever buildings it can find. It'll bring in whatever roads it can find. And now I have a little bit of New York City right at my fingertips, right? And you saw that there was no smoke and mirrors. I did that simply by choosing Model Builder and bringing that data in, right? So there's New York City for you. On that topic, I'm going to go ahead and just start off a brand new file, right? Let's just say new. Let's talk about land use and other functionality within InfraWorks. So I went, as part of my demonstration, want to show you that not only can you bring in three-dimensional data to look realistic, you can use it to also look schematically and understand a little bit more about a particular area or site. So as an example of that, I went and I found the Manhattan Primary Land Use Tax Lot Outputs, Pluto, right? Available online for free as a shapefile. If I go ahead and I sort by type, go ahead and I find that shapefile. You can see here the file is about 7 megs. I can drag and drop that information in. I'm going to call it buildings for now, and I'm going to show you what metadata is and why it's relevant. Address, just bear with me. I'll explain all of what I'm doing very shortly. And I'll go ahead and I'll just click close and refresh. And bringing that tax map data as buildings gives me something useful. Now, if you were to look at this from this perspective, right, it's just silly, barely off the ground. It gives me an idea of what all the different tax lots are inside of Manhattan, but not much else. Well, what information is really in that metadata? Well, if I were to bring that same data inside of Civil 3D, you'd see that if I bring up my table associated with all the metadata, that there's tons of data in here, right? Block numbers, lot numbers, school districts, zip codes. All right, all useful. Address, that's kind of nice to have. But what might help me here in terms of land use? Well, there's a land use code. That's great. That's a good start. How about building heights? Maybe I would want to actually show this projected in 3D. Well, if I look through here, I finally come across, and I know it's in here, I find a number of floors, right? Well, a number of floors doesn't tell me an elevation value, but I can sort of extrapolate that into a rough idea of how big those buildings would be, right? So how would I use that information in InfraWorks? Well, again, I can take metadata, 2D text data, and leverage that. First, by making the buildings appear relatively high compared to their number of floors, in which case I can write a very simple expression. You're going to see that I can go ahead and use the metadata that's built in. So I can use something called number of floors. I'm going to multiply that value, which may be 1, 2, 3, up to however many floors. I'm going to multiply that by 12. And in case that value is null, I'll add 1. So what it's going to do is it's going to take the number of floors, let's say 20, multiply by 12, give me a value of 240, and add 1. Right? If this value was 0, then at least I would have a 1-foot reveal to know that there was something there and it wouldn't be nothing. I can go ahead and set that to feet, and if I click close and refresh, you can see that my buildings will be projected up by the number of floors times 12. Now, it's not going to be perfect, but it gives you a sense of scale to the overall site that you're looking at, in this case, Manhattan. You'll see in instances where the World Trade Center sites are located, it's all one tax lot. Same goes for Madison Square Garden and other buildings. But for the most part, you have a very clear, at least relatively speaking, understanding of how large the buildings are in the surrounding areas. Now, what about land use? Well, again, I won't have time to do it from scratch, but you're going to see I can apply a style rule that I wrote earlier that allows me to specify a value from the properties of that data. Now, if you recall, I configured my description to land use. So it maps the description to a variable called land use that's pulling the data from the metadata in the shapefile. What I can then do is simply tell InfraWorks to create, actually, let me import it, to create a series of rules that allows me to map, of course I have it in another directory, bear with me, that allows me to map the land use values to a particular color. Now, I went online and I did some quick research, and I found that certain colors were mapped to a particular type of land use value, right? 1 or 2 family buildings, multi-use, commercial, open space, etc. And I went and I mapped each one of those to a particular variable and assigned it a color. That way, when I now run this rule, you'll see that it's going to color code every building based on its land use. Right? So again, very quick and easy way to get a graphic for an area where you have that sort of metadata. So you can see here all the different areas of Manhattan arranged by land use with the building projected heights approximately to the location of where they are. All right. Now, this leaves us with only a few minutes left. So what I'd like to do is point out one of the questions that I was probably asked the most, and it is, how do you find this information, right? Well, Google is pretty handy as a tool, but you maybe need a little bit more information than that. Fortunately, Autodesk has published a great white paper on this, and I'm going to go ahead and bring it up. We'll provide the link for you, and I'm just going to bring that up, right? This is from 2014. It's readily available on Autodesk's website. We'll provide the link in the follow-up email that we send, but it gives you a ton of information about how to find particular types of data, right? How to find terrain. And you'll see here it gives you an explanation of what it is. How do I find the data? They give you some ideas for websites. In the cases of other types of geospatial information, they'll give you ways to do a search. So for instance, if I look at how to find ground imagery, they'll say, do a Google search using the following strings, right? GIS plus data plus color plus aerial plus imagery plus download plus wherever it is your design is, right? So using this as a backbone, you can usually find a ton of other information. Last but not least, how does that translate into something you could find? Well, one particular district here in the immediate area, right, Westchester County, if I can spell it correctly, offers an extensive amount of geospatial information. So you can go to their data warehouse and you can find municipal tax map data, you can find 2-foot topos, you can find LiDAR, you can find planimetrics, transportation, environmental. I mean, it's just a wealth of information. And again, it would be just dragging and dropping that information into your InfraWorks. And again, to show you that I'm not doing anything tricky here, right? I'm just going to start a new drawing. I'll call this Westchester. I do have some information from there, right? And I'll go ahead and I'll bring that in through data sets. Let's go to geospatial data, New York, Westchester GIS. You'll see here I can just bring in all the roads in Westchester County by just dragging and dropping, choosing an appropriate type, and knows where it's geolocated already, close and refresh, and there's every road in Westchester County, right? So if you're doing a project up there, you have access to all that information. You can generate very quick. Right, if I zoom in, bear in mind this is all of Westchester County, right? So it's a huge, huge file, right? But you can see InfraWorks devoured it pretty quickly. I can do the same for anything else. Let's see if I have a couple of planning. I have land use map, so I can go ahead and pull that in as well for Westchester County, right? Again, I'll just call this a coverage area maybe. And you'll see that it's going to go ahead and process that data and bring it in 1, 2, 3.